Welcome back again. Now we're going to go over the example that we drew out in MATLAB now. In the previous lecture, I asked how we would get just this row here, right? Because this matrix, I'm gonna comment this out. This matrix here, if we take a look, has 3 rows, 3 columns. Okay, so it's a perfect candidate to split up because we can play with it many ways. Right, so I said I wanted the first row, which is 1, 2, 3. So we use colon notation. We'll say A2 equals A, right? We want to reference a matrix that we're trying to cut or subarray. Okay, we want the first row, but we want all columns. Okay, we want the first row, but we want all columns. So remember, we want 1, 2, and 3. Okay, and obviously 1, 2, and 3 are all columns, but we only want the first row. So we have the first row and all columns. So our colon notation works that way. Beautiful. Okay. Now the second example was where we wanted the first and second column, right? So 1, 4, 7 and 2, 5, 8. Okay. And that was also, we showed it on by drawing it, right? So remember, what's the question we always ask? How many rows do we want? So in the previous example, we only really wanted 1 row. In this example, we want all rows, right? We want all rows. So if we want all rows, we would say colon notation, colon, right? All. And which columns do you want? Well, you want the first and second column, right? So this again is colon notation using a subarray. This begin, end. Remember, there's only skipping by, there's default skip is by 1. Okay. So now we're going to get 1, 4, 7 and 2, 5, 8. Okay, so you can do this with colon notation in a subarray for the column. Okay, and then the other example was, what if I wanted the first and third column? Okay, the first and third column. So the first and third column, are we getting all rows? We are getting all rows, right? So 1, 4, 7, all rows. 3, 6, 9 is all rows, but we only want the first and third column. So easy, right? We start at 1, we skip by 2, and we end in 3, right? So this is a subarray colon notation, and what this is going to do is it's going to give me 1, 4, 7 and 3, 6, 8, and that will be my subarray in A2. So if I do that for 7, 3, 6, 9, okay, skipping the second column because I did a skip here, but I want all rows. Okay, so that's simple, very simple enough. I mean, if once you get the hang of it, it shouldn't be too hard. Okay, it shouldn't be too hard. So let's look at one last example here. Let's say I want only the second column. Okay, so the second column tells me that I only want I want all rows, right? So that's the first question. How many rows? We want all rows. And which column do we want? Well, we want the second column. Okay, and by doing that, I have 2, 5, and 8. And then this is now, A2 is now converted into a vector, column vector. Okay, and we can see that the type, if we do who's A2, it's a 3 by 1, right? That's what 3 rows, 1 column. It's a double, right? The data type for each one is a double, and it's storing 24 bytes of storage. Okay, so it's the class is a double, meaning it's the data type is a double. Okay, and it is a matrix. Okay, in this particular case, it is a column vector. Okay, it's a column vector. Now, if I wanted to transpose that, I can do this, right? So I turn a column vector into a row vector with the transpose. Okay, so that's simple enough again. Very, very easy. Now, there's one other lesson I want to teach you, because right now we're extracting data. You could also do assigning of data using colon notation on the left hand side. Okay, so here's a cool trick here. Okay, so let's expand this matrix a little bit so we could play with it further. 4, 5, 6, 7. We'll do 8, 9, and 10. Okay, and I'm sorry, and 11. Right? So let's comment this out. We can take a look at our matrix, have a visual. So if we take a look at A, you see it's going to be a matrix with 3 rows and now 4 columns. Okay, 3 rows and 4 columns. Now suppose that I want to replace the 1 and the 4 and the 4 and the 7. So what I want to do is, let's take a look at what I'm talking about here. We want to do, let's do B equals, let's say we have this these values, right? So 20, 21, 22, 23. We'll run that. So again, we have this matrix here, and I only want to replace the value 1, 4 and 4, 7 with this matrix. So 20 will replace 1, 22 will replace 4, 21 will replace 4 here, and 23 will replace 7. Okay, so now how would you do that? What do you think you're gonna do? Very, very simple if we go back to basics, right? So you gotta ask the question. What are we replacing? Okay, well, we're replacing the first column and rows 1 and 2, right? And we're replacing the 4th column, rows 1 and 2, right? So if I were to, the way that I would do this, okay, if I would first test an extraction, okay, of the values that you want to replace. So in this case, I wanna replace this, 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 and this. So what kind of colon notation expression would you try and do to get 1, 4, and 4 and 7? Okay, so let's do it. So it's very easy. Okay, let's just call this A1 is equal to. So what do we want? We want the first and second row, right? That's what we want. We only want the first and second row for the row, right? We don't want all rows because we don't want to replace 8 or 11. We only want the first and second row. Okay, and then what columns do we want? We want the first column and the 4th column. So what I can do is I can create a kind of a sub-index here and do 1, 4. Okay, so first I'm just extracting. Okay, I just want to extract because I want to make sure that I am getting the appropriate values from this matrix. Okay, so if I run this, let's see if it doesn't give me an, okay, so it gives me an error. It may be because, let me take a look here. Okay, so we have to make sure that we are referencing A, right? We initially said that we want the first and second row because we want 1, 4 and 4, 7, right? And then we want the first and 4th column. Okay, so we can do square bracket and reference it in by index. So the first column and then the fourth column. Okay, and so that in turn, okay, is going to give me what I need. So if I do A1, see I have 1447. Okay, so I was able to extract that. Now, I want to replace that actually. Okay, I want to replace those values with this B here. Okay, so what I could do is I'm going to take this, and instead of putting it on the right side, we're going to put it on the left side. And we're going to say, um, 20, 21. Okay, then 22, 23. Okay, and then if I write out A, okay, so this is to write it out. My new matrix should have the A replaced. Well, it's not new, it's overwriting the current matrix. We're going to replace 1 with 20. We're going to replace 4 with 22. Okay, we're going to replace 4 here with 21, and then the 7 with 23. So let's run this real quick. And then we have 20 and 22, 21, and 23. Now, I could also replace, instead of actually doing the whole matrix, I could also replace it with the B, right? Because B is this matrix here. So if I want to do shorthand, okay, then this will also work. So if I run this, you'll see again, it takes the same effect, okay? And we're able to overwrite matrix A. Okay, I think it's important that we look at this replacement, because this is the last thing we're going to talk about in this lecture. I think it's important to look at this replacement on our board. Okay, so let's head on over to our board, and then we can look at this example. We have a matrix. Looking at this on our board now, we have 1, 2, 3, 4, then 5, 6, 7, 8, 9, 10, 11, and 12. So it's 3 rows and then 4 columns. Okay, and the initial requirement for this problem was we want to replace this and this. And I said when we want to replace, we originally want to start out by just creating a colon notation expression. So let me just say this is A, and try and extract the columns, right? And we did that, right? So we said that if I wanted to extract this, right, we want the first and third and fourth row, right? I'm sorry, the first and second row. So this is first row, and then this is the second row. Okay, so we'd say from 1 to 2. And then we also want which columns do we want? We want the first and fourth column, right? And we came up with doing it this way, right? So we had 1 and then 4, and we can index them that way. So this gives me the first column and the fourth column, and so that's this, right? And then the first and second row are represented by this expression here, which is 1 colon 2. Okay, I could have done the same in terms of index and done 1 to 2. That's perfectly fine. Okay, so there's many ways to do this in actuality. So now that we have our colon notation, we'll figure it out. Then the second part is easy, right? Because, let me put this back. We wanted to replace these here so that A ends up looking like this. So you want 20, 22, then 9, 2, 6, 10, 3, 7, 11, 21, 23, and 12. Right, so this is our new matrix, what we want. So all we have to do is put this equation here on the left side. So we do something like A of, we want 1, colon notation, right? 1 to 2. Replace this is equal to, okay? And we'll say 20, 21, semicolon, running out of space here, semicolon, 22, and 23, which overwrote our values on our matrix, okay? And we saw that on the MATLAB. We saw that on the MATLAB. And I think this would most likely make more sense as to what's actually happening. Okay, what's actually happening. Another example that I can give you is, let's say we wanted not the fourth column, but we wanted to replace the third column. So I would just change this, instead of a 4, this would be a 3. But now if I do 1, 3, then this changes, right? So we'd have the following. We'd have 22, 23. Okay. I'm sorry, 21, right? 21. Sorry about that. 21, 23. And then this stays the same. We'd have 4 and 8. Okay. So the colon notation now using the subarray is going to be on the left-hand side, versus when you do an extraction, it's going to be on the right-hand side. So I hope that enlightened you a bit, and you understand now how to play with the subarrays using colon notation and extracting. Okay, because this is important. It's a good base once we get to solving some engineering problems. So I hope to see you on the next lecture.